Hello students, in this video we are going to discuss about the large sample test for the difference of means. In the last video we have discussed that test for a single mean. So basically we are using this particular concept when we are given two samples instead of a single sample, right? So in this case the working procedure is same like we have discussed in our last video also, that we are going to follow the step. So the first one is we need to set up the null and the alternate hypothesis. Null and the alternative hypothesis. Then the second step is we need to set up the level of significance. Third step is we need to calculate the test statistics, and the fourth one is we are going to compare this value, and on the basis of that we are going to draw the conclusion, right? So in case of difference means, because we are given the two different samples, so let the sample size be n1 and n2, and because it is a large sample test, so definitely the value of n1 and n2 should be greater than or equal to 30 only. So both the sample size should be large. This is the first thing. Second thing is in this case, because we are given two samples and we want to test the difference of means, so in this case our null hypothesis means both these sample has been drawn from the same populations. This is our assumption, or we can say that there is a insignificant difference between the two population means. Okay, so our null hypothesis would be mu1 minus mu2 is equal to 0. Okay, or if it is equal to given as some value d, accordingly we are going to decide our null hypothesis. And what is our alternate hypothesis? The alternate hypothesis is either this is not equal to, if it is d, or it is greater than, or it is less than. That is either it is a one tail or two tail alternative. So, okay, so based on the given information only we are going to decide that either one is greater than another one, or the second one is smaller than the other one. So on the basis of that we need to then select the level of significance, either it is 1%, 5% or 10%, and we are given the value of test statistics, the critical value. We can refer this critical value table, and then the part is the test statistic. So because the formula for the test statistic is same, which we have discussed even in our last video also, that it is t minus expectation of t upon standard error of t, right? But in this case what is our estimator? Because in this case we want to test for the significance of difference of mean, so in this case our estimator t will be the difference of sample mean. T is equal to x bar, x1 bar minus x2 bar, right? And what is expectation of t? And we know that expectation of x bar is, because we know that sample mean is the unbiased estimator of a population mean, so expectation of x bar is mu. So by using the linearity property, so if we say that it comes out from the population whose mean is mu1, and it comes out from the population whose mean is mu2, so expectation of t is mu1 minus mu2. And the next one is the standard deviation. Firstly we need to calculate variance. So variance of x1 bar minus x2 bar, and because variance is, because we are assuming that this is a simple random sampling, and simple random sampling all the random sample observations are independent, so on the basis of that we have the formula. It is variance of x1 bar plus variance of x2 bar, and we know that variance of x bar is equal to sigma square upon n. So if this variance is sigma 1 square and this is sigma 2 square, then this is the formula we have. So what is the formula here? It is x1 bar minus x2 bar minus mu1 minus mu2 upon standard error, means square root of variance, that is sigma 1 square upon n1 plus sigma 2 square upon n2. Now on the basis of this we have two different cases. Two different cases means case number 1 is if both the sample has been drawn from same population and the population standard deviation is known. Population standard deviation is known. So in that case, this is our assumption that sigma 1 square equal to sigma 2 square is equal to sigma square. Then our test statistic will be, in that case our test statistic will be z is equal to x1 bar minus x2 bar minus mu1 minus mu2 upon square root of sigma square upon n1 plus sigma square upon n2. Because both the sigmas are same, so it can be taken outside, so its value will be x1 bar minus x2 bar minus mu1 minus mu2 upon sigma times square root of 1 upon n1 plus 1 upon n2. So this is the case if their population standard deviation is known. Now case number 2 is if the population standard deviation is unknown. If the population standard deviation is unknown. So if the population standard deviation is unknown, then in that case your test statistic will be, then we can use that expectation of S square is approximately sigma square for large sample. Right, so we are going to replace here population standard deviation with the sample standard deviation, that is x1 bar minus x2 bar minus mu1 minus mu2 upon square root of s1 square upon n1 plus s2 square upon n2. Right, so this is the formula for the test statistics. Another important thing is sometime the question is about confidence interval. So if the question is 100 into 1 minus alpha percent confidence interval, like for example alpha is 5%, 5% means 0.05. so if alpha is 5% means its value is 0.05, so it is 0.95 into 100 is 95%, right? So what is the formula? So in the last case we have discussed that for mu the formula is x bar plus minus z alpha sigma upon square root of n upon or s upon square root of n. Okay, because generally population standard deviation is unknown. Okay, so if we are calculating confidence interval for two different samples, so in that case we are going to replace population standard deviation with a sample standard deviation, right? So here x bar is replaced with the difference and standard error. Basically this is the sample mean plus minus z alpha times standard error, right? And this is the standard error. This is the standard error, and this is the formula of standard error, right? So what is the confidence interval? This is x1 bar minus x2 bar plus minus z alpha time standard error, right? And what is the standard error? It is equal to square root of s1 square upon n1 plus s2 square upon n2. Okay, sometime direct question is asked that what is the formula of standard error, then we can use this formula, or sometime the course we are given a data and we need to calculate the standard error, then we can use this formula at a specific level of significance, we can calculate its value, right? Okay, so let us see that how can we implement this in the subjective problems first. Okay, so in this question the means of the two single large sample of 1000 and 2000 members are 67.5 and 68 inches respectively. So in this particular part we are given here two samples with sample size n1 is 1000 and n2 is given here 2000. This is the sample size given here, and the sample means are given here, like x1 bar is given here 67.5 and x2 bar is given here 68 inches. Can the sample be regarded as drawn from same population of standard deviation 2.5 inches? Same population means mu1 should be equal to mu2. That because both the sample has been drawn from same population, it means that their population mean should be same and standard deviation is 2.5. So population standard deviation is given here 2.5. Okay, so on the basis of this, what will be our null hypothesis? So here our null hypothesis is h0 such that mu1 minus mu2 is 0. Okay, that both the sample has been drawn from same population. And what about alternative hypothesis is that they are not, means they are from different population. Different population means mu1 minus mu2 is not equal to 0. So basically it is a two-tailed alternative, right? So what will be the level of significance? Because it is not given, so when it is not given, so by default we can consider 5%. So we are considering 5%, and for two-tailed at 5% level of significance, its value is 1.96. So the value of mod of Z alpha is 1.96. Okay, so the next step is we need to calculate the test statistic. So what is the value of Z? x1 bar minus x2 bar minus mu1 minus mu2 upon. Now because in this case the population standard deviation is known, so we are going to use first formula, this one, because population standard deviation is known. So our standard error formula will be sigma into 1 upon n1 plus 1 upon n2 its root. Okay, so because we are assuming here mu1 minus mu2 is 0, so it means that this term is 0. Okay, so this thing we need to keep directly on the basis of the given assumption only, right? So what is x1 bar? 67.5 minus 68 minus 0 upon 2.5 times square root of 1 upon 1000 plus 1 upon 2000. So its value is minus 0.5 upon 2.5 into square root of, this is 0.001 and this is 0.0005. 2000 means 0.5 and 1000 means 30. So its value is if I calculate 5 on the 5 got 25. So minus 1 by 5 means minus 0.2 upon square root of 0.0015. Okay, and if we calculate this value using calculator, say, so its value is 0.2 divided by 0.0015 root. Its value is 5.16 with a negative sign, minus 5.16. So you can see here its value is 1.96, means critical value 1.96 means its value is from minus 1.96 to plus 1.96. So this is the acceptance region and this is the rejection region. So because the value is minus 5.16, definitely it falls in the rejection region only. So what is the conclusion? Because Z calculated is falls in a region of rejection, hence null hypothesis rejected. So it means that there is no enough evidence which proves that these two sample has been drawn from same population of standard deviation. Okay, so what do we conclude here? That the two samples we can't say that the samples have been drawn from different population. Okay, or we can say that the two sample has been drawn from we can't say that the sample has been drawn from same population of standard deviation 2.5 inches. Okay, so because the calculated value falls in the region of rejection only, so null hypothesis rejected. So we can say that their population means are not same. So there is a significant difference between their population mean. That's what we can conclude here. Okay, let us try another one. And the another question is the average hourly wage of a sample of 150 workers in plant A was, means the first sample size is 150 and average wages are given as 2.56 with a standard deviation, sample standard deviation is given as 1.08. Another average hourly wage of a sample of 200 workers, their average wages are 2.87 and the standard deviation is given as 1.28. Can an applicant safely assume that the hourly wages paid by plant B are higher? So you can see here they are paid rupees 2.87 and they are paid rupees 2.56. So definitely this is greater than this one, but we want to check that either this difference is significant or insignificant, right? So firstly we need to set up the null hypothesis. So what is the null hypothesis? Like I told you, null hypothesis means no change, means there is no significant difference between their average wages. There is no significant difference between their average wages. Right? And what is the alternative? Alternative is that plant B, that is second one, are paid higher than the plant A. So it means it is less than 0. Means mu2 should be greater than mu1. This is the left tail alternative. Okay, because plant B are higher than those paid by plant A. Okay, so the next one is the level of significance. So it is not given here, so we are choosing alpha as a 5%, and at 5% we know that its value is 1.96. So now we need to check the test statistic. So to calculate this, because in this case population standard deviation is not given, rather sample standard deviation is given, so we are going to refer the formula for this one, where the population standard deviation is unknown. So what is the formula? x1 bar minus x2 bar minus mu1 minus mu2 upon square root of s1 square upon n1 plus s2 square upon n2. So because we are assuming that their population means are same, so this value is 0. So x1 bar is 2.56 minus 2.87 upon square root of S1 square means 1.08 square upon N1, S2 square 1.28 square upon 200. So if we calculate this, this is minus 0.31 upon, if we calculate here 1.08, its square divided by 150 plus bracket 1.28 square divided by 200 bracket close, 0.15968. if we take the square root, its value is 0.126, and if we take its reciprocal and multiply it with 0.31, so its value comes out to be minus 2.45. okay, so this is the normal distribution. So in this case the critical value is 1.96, so this is minus 1.96 to 1.96. so this is the left tail, this is the right tail. Two tail means that this is the region of rejection and this is the region of rejection, but here we have applied left tail test. So in this case Z alpha is minus 1.645. okay, so for left tail 5% level of significance, right, so it is minus 1.645, not 1.96, right. So in this case our 5% region of rejection is entirely in the left hand side only. So in this case the entire region is in the left hand side, minus 1.645, 5% is the region of rejection in the left hand side only, but the calculated value falls in the region of rejection because this value is smaller than this one, so this value definitely falls in the left hand side of this one. So because Z calculated falls in the region of rejection, so what can we conclude from here? Null hypothesis rejected. okay, so because the calculated value falls in the region of rejection, because at 5% its critical value is minus 1.645 and this value falls in the left hand side, so null hypothesis rejected. So what can we conclude here? So we can conclude alternate hypothesis is true, means plant B workers paid more than those by plant A, means the hourly wages paid by the plant B are higher than those paid by plant A. So it means that the plant B workers, they are paid higher wages than plant A workers. okay, so this is the conclusion in this case. okay, let us consider another one. So basically this is one MCQ type problems based on this topic we have considered. So two surgical procedures are widely used in a treat. To compare the success rate of the two procedures, a random sample from the two procedures obtained and the number of patients with no reoccurrence of the disease after 1 year was recorded. So this is the procedure A. On an average, the success rate of the two procedures are given here. So the success rate is 78 and here is 102. So 95% confidence interval for the difference in the success rate is. Okay, so I think basically this problem is based on the proportion only. So in this case, although it is not the part of the topic, but anyhow in this case we need to calculate the number of occurrence. So what is the success rate means the probability of success. In this particular case, P1 is 78 upon 100 and P2 is 102 divided by 120. This is the probability of the number of occurrence upon the total number of samples, right? So in this case 95% confidence means, so we want to find out the difference, capital P1 minus capital P2. It should belongs to P1 minus P2 plus minus Z alpha times standard error. Okay, and standard error is a standard deviation. So standard deviation of P1 minus P2 is, we know that in case of binomial distribution the standard deviation is sigma is npq, sigma square. Okay, so sigma upon square root of n is square root of pq upon n. So in this case this is square root of p1 q1 upon n1 plus p2 q2 upon n2. So we can calculate this particular value. So it is 0.78 minus 102 divided by 120. 102 divided by 120, so 0.85. So 0.85, and Z alpha is 1.96, and standard error is square root of P1 into Q1. It is 0.78 into 0.22 upon 100 plus its value is 0.85 into 0.15 upon 120. So if I calculate this value, 0.78 multiplied by 0.22 divided by 100 plus bracket 0.85 multiplied by 0.15 divided by 120, and we take its square root and multiply by 1.96. So its value is 0.103. So you can see here its value comes out to be minus 0.07 plus minus 1.03. Okay, so basically this the correct answer comes out to be this one, because the difference is given as positive, so they have considered this as the first one, this as the second one. Okay, so basically the formula for test statistics is same, t minus expectation of t upon square root of variance of t. So in this case your estimated t is a proportion p1 minus p2, and expectation of t is expectation of p1 minus expectation of p2. In this case this is capital P1 minus capital P2. Okay, so because basically what is P1, it is x upon n. So expectation of x is equal to n into p in case of binomial distribution. So what is expectation of P1 means expectation of x1 upon n1. So it is 1 upon n1 into capital P1. n1 and n1 get cancelled out, so its value is P1 only. Okay, and what about variance? Variance of P1 minus P2 is variance of P1 plus variance of P2, and variance of P1 is x1 upon n1 plus variance of x2 upon n2. So this is 1 upon n1 square into n1 p1 q1 plus 1 upon n2 square into n2 p2 q2. So 1 power of n1 and n2 get cancelled out, so its value is p1 q1 upon n1 plus P2 Q2 upon N2. Okay, so basically formula is same, but it is not the part of the difference of mean. Okay, so I have considered this particular part because we are given two sample, but basically this is a problem based on proportion. Okay, anyhow, you can try the problem based on the difference of mean. If you still find out any doubt or any query, you can post your query. I'll try to provide you the solution of the same. Right, thank you, have a nice day.